Okay, let us start the tutorial. Um, I think we stop at question 9 from the students in for tutorial 1. So maybe we can, anyone want to um, share screen or share your answer for questions 9? Let me check. Yao Ting Long, is it okay for you to share your answer for question 9, tutorial 1? Are you there? It's okay. How about Yu Yang Chua, the one with Patrick Star? Not here as well. Ah, yeah. Okay, how about share screen? Yeah, please. Whenever you're ready. I found that you all like SpongeBob a lot. All are similar, profile. Okay, one moment. Let me check what is the questions. Mm, compare the advantage and disadvantage between bitmap and vector graphic. I think this one is very common. Can you enlarge a bit? Okay, great. So bitmap advantage, low memory use. Disadvantage, image will blur when enlarged. Advantage for vector would be image remain unchanged when enlarged. Disadvantage, high memory use. Okay. Okay. Thank you for your answer. Very simple. Um. Again. During the always when you answer the questions, you must very aware. The marks given for the question. Okay, I found that of course you are not the first year first semester. I think you all already quite well versed in tips and tricks for answer examination question or eventually for assignment and etc. Uh, just serve as a reminder lah. For examination question, always check with the answer. I mean, not the answer, the marks allocations. If it is meant to be more than 3 marks, maybe 4 and above, perhaps it is meant to discuss further. If you only give me, of course, if it is only 4 marks and discussing 2 different items and asking for advantage and disadvantages, so perhaps the answer given by Yu Yang Chua would get full marks. Okay, provided the answer is correct. If it is meant to be maybe 6 or more, then perhaps you need to further explain a bit. Okay, to be play safe, further explain a bit, especially in your uh, lab report and also assignment. Make sure you really provide the discussion, the conclusion accordingly, especially for the conclusions. Because for the previous batch, they did provide the conclusion, but in very brief, like maybe 2 sentences. The marks allocate for the conclusions is like, I think, eight mark or something more than that. So you should provide something in details. Okay, of course you no need to repeat everything, but at least you need to provide something in depth, not like superficial, just 1 line or 2 lines, 2 sentences. I cannot give you a full marks lah. Okay, the same apply to examinations. These are the tips and tricks. Eventually, at the end of the day, I mean, yeah, you need to gain knowledge in MTAA, but at the end of the day, you still wish to score your examination, right? Okay. So let me share my screen. Okay, I believe can see. So compare the advantage and disadvantage between bitmap and vector graphic. So this is when you look into the uh, chapter 1, it is obvious that which part is important. Because when you look at it, when you try to, when you go on a trip, when you're back from the trip, for sure there will be something that is remarkable, and is most probably you can remember it when you are telling your friends your journey to somewhere else. Okay, the same thing here. When after you done the lecture for chapter one, perhaps there would be something is much more significance in any chapter. Okay, there might be part of that which is so-called the um, important part, important point or bullet points for that particular chapter. So for chapter one, perhaps bitmap and also vector is part of it, and of course the typeface as well, the basic elements. So these are those part which is quite important in chapter one. Okay, so it's important for you to know to differentiate between bitmap and vector, discrete and continuous, dependence and independence. What else? Linear and non-linear, sans serif and serif. All those are quite common, okay, and it is important for chapter one. So for this one, the advantage would be basically is from lecture notes as well. Composed of pixels, the color of every pixel of a bitmap circle is allowed to change. And disadvantage, bitmap graphic files are larger than vector file. That is because you need to each of the pixel will keep the memory. Will keep the memory for the pix intensity 0 to 255. Let's say this is a grayscale. So you would have a larger file size for bitmap graphic. But for vector, always remember vector is generated by equation. So you cannot really process the vector graphic because it is generated by equation like y equals to mx plus c. So if you want to determine the x value, you give the given the y value, you can determine something like that. So you just input your um, uh, current pixel, then it will generate the intensity later on. Okay, so this is how the vector is being formalized, which is using the mathematical equations. But the in-depth knowledge, I mean, in details, how vector is being formalized is not discussed in our, in MTAA lah. And nonetheless, because it is not involved in basic image processing. Okay, so can the advantage for vector is can resize and rotate the graphic without distortions, and especially this is important in the uh, advertisement and marketing industry, the printing industry, because you don't want to print something very blur, like those graphic logos printed on your key. You don't want the logo, when you drag the logo and then when you print out the um, logo or whatever alphabets on your t-shirt, then it's become very blur. Okay, you definitely don't want something like that. The same thing apply to the advertisement and marketing industry as well. For advertisement, poster, the what else? The company logo and etc. Okay, for promotion purposes. So smaller file size because the graphics are stored in a set of instruction. Therefore, the file size can be significantly smaller than bitmap. Okay. For disadvantages, the bitmap basically the file size is larger than vector lah. And for the vector, the file size get larger when the graphic get complex. And they take longer time to appear on screen. That is because it involves more and more complex instruction and also equation. So sometimes when you want to display something very complicated, it takes time to display because you need to recalculate and reiterate the equations and also the instruction. So cannot display photorealistic quality, and the quality of the image is low. Uh, what is meant by here is that you cannot really display something. Um, this one only become true whenever you have, for example, you snap a picture of nuclear cell. It is very small, and you convert it to vector. Once you convert the bitmap images to vector, it will become very. The entire information or the meaning of the image can disappear. Which means if you have, let's say you have a nuclear cell, Let's say you have a nuclear cell, nuclear cell, and it is very small, and you try to enlarge this cell, and later on you convert this bitmap cell to vector. You may have, because the vectors are the nuclear cell might have fuzzy, very a lot of fuzzy pixel here, because the cytoplasm and etc. There are some of the ribosome, the membrane and etc. Clouded across the entire cell. So when you convert this bitmap image into vector, it might become something like this one. The entire block become one color only. So it's like, the entire block become maybe, for example, this one is more to black color. The entire block become black color. So basically, when looking at a black dots, it is like the entire meaning of the original bitmap image is already lost. So this is why meant by here like quality of the image is lower. Okay, especially for those that have fuzzy scale. For example, the shading of the image. For example, this is a like a sunset. Sunset, and then you have a different shading here, the golden color, red color, orange color. Whenever you convert to the uh, vector image, it will looks like one patch of color over there. So this is what is meant by the quality of image is lower and the photorealistic quality cannot be displayed. You cannot display something like the one that you snap with DSLR. You want to display the sunset images and etc. Is not so possible. Okay, especially when the shading is very obvious, significant throughout the entire image. So you would found after you convert you may found different color patch over there, maybe red, maybe this side red color, this side orange, this side gold color, something like that. The meaning is being lost and etc. Okay. So state the reason why the bitmap is described as district. I think this one is very simple. Let me pick one. Oh, sure, sure, sure. Yeah. Do you want to share your screen or how? Yeah, good. Okay, bitmap is described as district as it store images in pixel, their coordinates and color without involving any mathematical. Okay, so let me share my answer. Okay, what else? In pixel. This is for Q10. Q10. Q10 is actually asking why it is district. The meaning of district is that it is not continuous. Which mean in signal processing, 1, 0, those are district, right? You don't have intermediate value. For example, male, female, or something else. So those are district as well. What else? For example, the color of the eye, black, brown, blue is district. Okay, but what is considered as non-district, which means it is something continuous lah. Which means the height of the height of the um, the height of the students in the class, the share trading, up and down, there is a train, and there would be flirt value between each other. Okay, so your answer is that they are coordinate without involving any mathematical equations and involve space dimension only. Perhaps the first answer is not so correct. Without involving any mathematical equation. Perhaps the first one I think is not so correct. But the second one, second answer is okay. Okay, it involves space dimension only. This one still okay lah because space let me think not so suitable as well. It's okay. This would be the answer. First of all, whenever although maybe sometimes this question is follow. I mean, it's just after this question. And question number 9 is to compare between bitmap and vector, right? But actually, question number 10 is totally different. It is not comparing with any with any with any other things like vector, you know. So bitmap is described as a district because it is made of grid, and each big part of the grid is known as a pixel element, which is pixel. And you have your intensity, you have your intensity value drawing. Oh, sorry. The intensity value is like a bar chart, 0 to 255. So you have different amplitude, maybe 100 and 200 and etc. lah. Okay, so this is what we call district lah, because you don't have intermediate value lah. Of course, there are some exception lah. If you normalize the value, of course, it does have the what we call the value or the flood numbers lah. Because when you normalize it to become 1 0 to 1, so perhaps you will get 0 point something else, right? So that is exception. But when we talk about 0 to 255, so it is actually discrete. Why? Because if you have 0, then you are 0. You are not intensity 1 and etc. Okay, so this is why we call it as a district lah. Okay, various number of color can be associated with each pixel depending on the number of bit. So basically, this is associated with the number of bit because the bit is actually describing how many color information this image can store. Okay, we do have 8-bit, 16-bit, 24-bit. Okay, of course, your computer does have 32 and 64 and etc. But when we talk to an image, usually it is in this kind of. Okay, so perhaps you would have 8, and also some is 2-bit and etc. So this is perhaps the grayscale, this is the index image, and this is the true color. So basically, when you have 8-bit, which means 2 power 8, you have 256 value. So cut off 1 for 0, and the rest 255. So basically 255 plus 1, you will get 256. So this is how you get 8-bit lah, okay? And for the 16-bit, perhaps some index image can be 16-bit. Depends on how the image is being organized and displayed. And for true color, is very simple because true color consists of 3 layers, right? Layer R, layer G, layer B. So basically each of it 8-bit. So 8 multiplied by 3, you will get 24. Okay. So this is why the bitmap is known as district lah. Perhaps for the answer given just now, do I have to mention about time? Let me think. Time, time. I would like to see how you relate this to time. Um, because time is not the first answer appear, when it comes to why this is a district, something like that. So if you're able to explain, I welcome your answer. Because because sometimes the answer is not, directly exactly like the answer scheme. So if I can read 2 times, I didn't write the limit. I can't relate. I see. Okay. Okay. Sometimes when you think and rethink, and you still cannot relate, perhaps you can consider that is a wrong answer. Okay. Try to think in another way around. Um, try to think in another way around because sometimes maybe the wrong part of the answer, I would say, because time depend when you talk about time, perhaps it is referring to time dependence and time independence. For time dependence, perhaps audio, perhaps video or animations, that then those are time dependence because you require a specific duration of time to know the meaning of the medium itself. For example, text, still image, you don't need any, you don't need to look at the image for few seconds in order to comprehend. The meaning is there already from the very first second. Okay, so that is the difference between time dependent and time independence. Okay, sometimes it would be a bit confusing, perhaps. maybe you are yet to very familiar with the lecture notes. Okay. If you are starting to be more and more familiar with the lecture notes, so basically you would know that, oh, it is actually different case. Okay. So let us continue. Let us continue. Question 11. Question 11, I think question 11 is should be very direct lah. Okay. I think I don't need you all to continue for question 11. Let me just show the answer. Because the question 11 is like everything copy from the lecture notes. Mm. Nonetheless, I will share this solution to the Google Classroom. Okay, so don't worry about that. If you have a further query, you can just find me like Google Chat and email whatsoever. Okay, so question 11. List three file format that used to store the information of image, audio, and video respectively. State also their application in different file format. So basically, you have to know some of it, okay? Because end of the day, I would hope that you all at least know, oh, JPEG is something, JPEG is actually something being compressed. Bitmap is the raw image. MPEG is something else, something like that. At least you should know, I hope you should know that when we want to process the image, we usually use .bmp, .tif, and if we want to remove the background, we usually use .png, and .jpeg and .jpg is meant for JPEG, which means it is used usually to compress the image. Okay, so the most common one, of course, the JPEG lah. But also at the same time, I hope you all know JPEG is the lowest in quality because the image is being compressed, but it has the smaller size as well because most of the high frequency information being removed. And the compression is sometimes depends. You cannot say that if you found that this is a .jpg, then it must be already compressed because this one we would learn in chapter 5, compression, image compression. Uh, because sometimes when we compress something else, but we compress with a scale of 1, which means nothing being compressed. Do you understand? For example, you divide a very large number by 1, which means you divide nothing lah. If you divide by maybe 100, divide by 10, so it is break down into 10 different parts, right? But if you only divide by 1, which means you did nothing lah, the compression ratio is nothing, which means before and after the compression, the size is remain the same. Okay, so please do not have the prejudice that, oh, whenever I saw JPEG, then for sure this is already compressed. No, not a must. Depends on the compression factor. Okay. So yeah, this would be some of the common one, the .bmp and .tf. .bmp and .tf would be some of the raw image that we usually process. Okay, we usually use these two types of extension. And .jpg is depends on the compression factor. Okay, the higher the compression factor, the smaller the file size and um, the worse the quality it is lah. Okay, because the higher the level you compress, more and more high frequency information being removed. Okay, this is for audio. Audio, you all might not be so familiar. Even I myself is not so familiar. But of course, I think you all know at .mp3 very well, right? Um, I'm not sure if you all know lah, because I think a bit different generations. Because at my age, .mp3 would be something very eventually we have some apps known as MP3 as well lah. Okay, so I'm not sure if you all still have these kind of things. iPod. Do you all even know iPod? I'm not sure that. Walkman. Do you all know? Last time we did have a very big disc. We known it as Walkman, and those with Walkman are very rich guy lah. Okay, but I don't think. Yeah, you did. I think we are same generation with Brenda. Okay. Let's get back to this. Yeah, iPod would be something nearer to your generations. Okay, but eventually now I think Apple is not selling iPod, right? Okay, I'm not sure. Okay. Let us continue. .wav and .wma would be if you did look into the because now I think no, no people will download the song or download the audio because last time if we want to listen a particular song, we have to download it. Eventually you buy the original CD. You play using your computer. It will shows the extension. But I think now it's less likely everyone is using Spotify, this and that. Okay, so perhaps the extension is not is there. Extension is there, but not really known to the public. Okay, so these are some of the common uh, file size for audio. Okay, we will learn MP3 later on because MP3 is actually it is the third layer We have MPE. MP3 is actually the abbreviation for MPEG, the MPEG that we call it as MPEG 1, MPEG 2, MPEG 3. Okay, so MP3 is actually the layer 3 Okay, the higher the layer, the better the compression is factor. The more complex compressions techniques is being employed. Okay, so this is why MP3 is most common and welcomed by different computer, eventually the uh, in music industry manufacturer. Okay, so for the video would be a bit different because video is audio plus the image moving images. Okay, so I think the most common one would be .mpeg. MPEG would be something quite common. MP4 and also WMV. Okay. MP4 is usually when you saw the .mp4, which means it is with graphic Okay. If MP3, which means usually not usually MP3 is without graphic Okay. So the rest of it might not so familiar perhaps, but at least you have to know some of it Okay. At least you have to know some of it Uh, at least you know, especially for images. Is quite important to us. Eventually, regardless to the MTAA to this subject later on, you also need to know because I think in Malaysia, most of the uh, students after graduate from E&E, they are usually working in the image processing industry as well because this is the current blooming industry, especially combined with AI and etc. So it's good for you to know at least some of it. Okay. So that is all for the tutorial one. One moment. Let me check with tutorial two. Okay. Tutorial two is quite simple. The involve only the calculations. Okay, I already upload tutorial two, and later on I think I will upload tutorial three Okay, because I think our chapter is now in tutorial three as well. Okay, we already covered tutorial three. Okay, so tutorial 2 is more on the image, the size, storage, and etc. Okay, the first question, determine the memory storage required for each of the following image in byte and kilobyte. Always remember, let me remind you all again. In examinations, I'm not sure how about others lecturers, but for me, in order to obtain a very accurate, um, accurate calculation, especially, please use at least 4 decimal place. Okay, if you use more than 4 decimal place in your calculation, is okay because usually the answer would be more or less similar. I would say 99% similar with the one that you use 4 decimal place. But if you only use 2 or even 1 decimal place, for sure the answer would be less than 70%, maybe around 70%. Okay, try to use 4 decimal place, and whenever you display the answer, write your answer, when it is involved flirt value, please use 4 decimal place. Okay, if it is an integer, then it's okay to leave it out. Um, okay, for our question one is about byte and kilobyte. Okay, again, check the questions. If the question asked in kilobyte, please give me answer in kilobytes. Okay, if not, no full marks will be given. Okay, so anyone wish to do for questions one tutorial two? Let me pick the lucky one. Um, Maylin Ong, do you want to share your screen or put the answer in the chat box? I think it's quite hard to put an answer in chat box for these kind of calculations. You got your way. Okay. One moment, let me check. The first one is 2, 3, 2. One moment, give me some time to check your answer. Okay, I think I did provide the notes in the lecture notes. I mean, a small compartment, highlighted with the notes. Okay, thank you for your answer. Let me share my screen. Okay, so this is tutorial 2 is regarding the calculations. I yeah, 310 the way of meaning on did should be correct, but lack of one step because you forgot to divide by 8. Okay, because 1 byte is equivalent to 8 bit. Okay, so remember this is the procedure. It's a bit different from calculating the normal, meter to kilometer, gram to kilogram will be a bit different. Always remember 1 kilobyte is equivalent to 1024 bytes. Okay, and 1 byte is equivalent to 8 bit. Now, whatever given here is bit, which means you have 320 multiplied by 240, and it is an 8 bit. Okay, so yeah, it's correct. You have to multiply by 8, but you have to divide by 8 in order to convert the bit to byte. Okay, so I think this is the step missing lah. So which means the answer will be different lah. So this is the answer 320 multiplied by 240. Multiply and divide, so cancel off. You get this one and divide by 1024, you get kilobyte. Okay, so this is the answer. And the second one is the same. Remember, this is the same actually. I mean, if you want just multiply 640 multiplied by 480 multiplied by 24 and uh, divide by 8 is the same. Okay, so you will get this answer. Let me assure this again. Yeah, the answer is correct. So again, the answer byte divided by 1024, you get kilobyte. The same goes to this. 1600 minus multiplied by 1200 8 bit, which is cancel out each other lah. You will get this one, and divided by 1024, you get this one. Okay. So always remember to I mean I know you all know the answer lah. Actually, just that you miss out one step, then 0 marks lah. Okay. Sometimes this one is like um what we call 3 marks. It is very simple and easy for you to pick up this type of scoring. Okay, because this is not considered as a high cognitive level questions because simple calculation only. Okay, so try to be extra away. And okay, question 2, anyone want to share their answer? Determine the number of color for each of the following image. This is to question 2 is to determine the number of color can be displayed. Let me check. Boon Kyung Koo. Can you share the answer? You want to share your screen also can. Else you can put it in the chat box. Um, 4 and 3. One moment. I think I'm asking for I don't get it. Question two, 4 and 3. What you mean by 4 and 3? You mean the answer is 4 and 3? Now should be question two. Question number 2A and 2B. Is to determine the number of color can be displayed in 16-bit index image and also 24-bit color image. You understand? 24-bit. Okay. How about 16-bit? 24-bit is correct. Basically, this question is just to ask. Yes, you are correct. Basically, this question is just to ask how many. I mean, for a 16-bit image, how many color could be displayed? I mean, the combination of color could be displayed. And of course, the answer, I mean, the 320 and 240 is nothing lah. Whatsoever the resolution, the image is a 16-bit still remain this color range. Okay, why you have this color range? Because one 8-bit image can store 256 different information, or you can see this as intensity. So if you have 16-bit, so which means you have combination of 256 multiplied by 256. Okay, remember not times two, because this is a combination for different color. And for 24-bit true color, you have basically, because it's mentioned two true color, right? So basically it's RGB. So since each of the layer you have 256, so basically 256 multiplied by 256 and get this one again, you will get around 16 million range of color. Okay, so this is why we say that this is why we say that by just a combination of three different layer, three different grayscale layer, which is R layer, G layer, and B layer, you can actually get 60 million different color. So with RGB alone, you can basically create all the color in this world. Okay, nearly all lah. Okay. So that it is anyone to present, want to share question 3. Chai Xiu Chia. Yes, okay. You may share your screen or put the answer in the chat box. I think this one is okay to put the answer in chat box. A and B. Oh, you got 3 questions. So you can give the answer for A lah. Answer the following question. A is define the meaning of bit that. Yeah, please. One moment. Bit depth is the number of color supported, which is measurable. Okay. Oh yeah. When I look into your oh, it's okay. For the final questions, I mean, because this final, the final examination for this semester would be in physical, right? Okay. Please extra careful on your handwriting, because nothing relate to Chai Siu Cha. Just a warm reminder to all of you, because you are going to write the answer, especially for those with justifications, you may need to write down the answer. So please write it, at least readable lah. Okay, I'm quite worried with those answer is unreadable, so I have to guess the answer. So if I have to guess the answer and later on you found that, oh, this is not the real answer, for example, 5 and 6, and the writer is, is a bit difficult for me to read. The 5 could be very similar to 6 and can result in a wrong answer. Okay, so try to avoid all these issue, because to request for, oh, this is a wrong marking, something like this is very tedious for both the parties. So please write properly lah. Okay, thank you. The answer for A is correct. B is, one moment. Let me check for B. What is the answer of B? Calculate how many bits are required to represent each pixel if each pixel is able to display. How many bits are required to represent each pixel? Okay. In a true color. So your answer is the x is equal to 24 bit per pixel. 24 bit per pixel. Okay. Per pixel. 1 pixel. Okay. And the last question is calculate the storage size required to storing the. Okay. What is the answer? Okay. I think a true color. Calculate the storage size required to store a true color image in Q3B. Okay. Your answer is 240 multiplied by 120 multiplied by 24. 0. Okay. Okay, thank you for your answer. Calculate how many bits are required to represent each pixel. If each pixel is able to display 256 color in a true color, n is the number of bit. Okay, sure. It is just my draft. Okay, great. Thank you. Let me share my screen, but I think my answer here is a bit different. Okay, so answer the first questions, define the meaning of bit depth. The meaning of bit used to represent a pixel, also called color depth or pixel depth. The bit depth determine the maximum number of color that can be displayed at one time. So basically, if you have an 8 bit, which means you have only one value. If you have 24 bit, which means you can have 3 value. Okay. But in MATLAB, by default, you would have the same value because anyhow MATLAB would display 3 value as well, uh, referring to RG and B. Just that the value for grayscale would be the same. For example, if you have 100, so you would expect 100, 100, 100. Okay, that is for the bit in the, I mean, how the MATLAB organize the bit depth. Okay, so the file size, how many space it takes up on a it also refer the bit depth also refer the file size, how many space it takes up on the disk, and it's determined by the number of pixels and the amount of color information that is stored. So basically, you would expect a larger file size. I mean, a high definition or HD image would have a larger file size. Okay, so this is normal. Calculate how many bits are required to represent each pixel if it is to display 256 bit color in a true color. I'm thinking of this question as well because a true color should have total up 24 bit. But for each pixel to display, you should have 2 power of n, and the n representing the bit as well. So 2 power 8, which means you have 256 lah. We hold on this question first. Look at the C. Calculate the storage size required for storing a true color image with 240 multiple by 120 pixel with a bit depth obtained in Q-Trade. This one. Okay. But I think this calculation is incorrect lah. Okay. So anyhow, you have to let me use this one. Should be 240 multiplied by 120 multiplied by 24. So that you will get 691,200. Okay, and divide by 8 bits in order to convert it to byte, 86400, and divide by 1024, you will get 84.3750 KB. Okay, so this should be the answer lah, which means shows by Chai Siu. Okay, this will be the answer lah. I will upload this one. I will correct this one later on. So with that, I believe this one should be 24 bit lah. Okay, not 8 bit lah. Okay, ignore this one and ignore this one. Okay, let us look into question 4. Let me see question 4. Discuss the main advantage and disadvantage of an index image as compared to a true color, which is 24 bit. Describe what is defined by the color map in the index image. Okay, I think this question is quite simple. Anyone to try? Let me stop my share screen. Jamming, jamming. Do you want to try this answer? Question what? Question 4, right? Yeah, question 4. Okay. Advantage would be index file size. Advantage in design. Okay. Advantage would be the file size is smaller true compared to true color. Okay, correct. Color image available in an unlimited amount of color. Not unlimited lah, but 60 million approaching unlimited. But still not unlimited lah. Okay. 60 million is a very big value lah, but it is not unlimited. Unlimited, which means infinity. Okay. Disadvantage, index image limited palette. Yeah, it's true. Color image, RGB color value is much larger compared the RGB color value is much larger compared to. So what is meant by color value? Does the color value mean 0 to 256? Sorry, 0 to 255? I'm not really understand the color value because to me, the color value should be the intensity lah, which means 0 to 255. Since you have 3 layer, which means you have 3 different definition. I mean, 3 different numbers for R layer, G layer, and B layer. But I don't think this is a disadvantage lah. Okay. An index image use direct mapping of pixel value to color values, color map values. The color of each image is pixel is determined by using the corresponding value. Okay. Basically, everything is correct. Just that the disadvantage for color image, to me, is not so appropriate because this is the strength of the RGB, which able to display a different, I mean, a wide range of color, different color lah. Okay. But if you put it like that, if you put in that the size of the RGB image is much more larger, which is 8 bit greater than the index image, then will be better lah. Okay. Okay, let me share my screen. Thank you for your answer. Okay, so these are the advantage and disadvantage. The storage size required by an index image is smaller. This is because only the index of the color map is stored. For example, this to display 256 color, then 256 index number are used. Thus, only 8 bit are needed per pixel. The disadvantage too is that only a limited set of color can be displayed, which means limited palette lah. The color map defines the RGB value for the selected color to be used. Okay, and color map is also called a lookup table. So basically, that it is we less likely to use the color map or the lookup table in our slippers. Okay, but it's good for you to know because it is something um I would say not something common to the public, but you have to know this because it is sort of uh, why this is a color image, but the size is much more smaller, something like that. Okay, it is something um should be known lah. Should be known that those that at least got knowledge in the multimedia lah. Okay, so we still got some time. So let us look in another question. Question 5. State 3 factors that could affect the size of digital image display on the computer screen. This one should be very fast. Um, who else? Gasing Wong? Is it Gasing? Gashin. Gashin Wong. Resolution setting, sign and oh yeah, okay, that's all. This is the answer. I think I don't need to share my screen. Okay, so this is the answer for the question 5, and it is inside the lecture notes as well. Okay, so far any questions, any doubts, anything to ask? No, okay, so we stop at question 5. Okay, if none, so that's all for today. I will upload the answer for tutorial 1 to the Google Classroom. And for tutorial 2, I will upload after we finish the discussion. Okay. If none, so that's all for today. Thank you so much and bye bye.